Good morning, students. Now we will discuss about open circuited transmission line. In our previous section, we had discussed short circuited transmission line. Similar to that, we have to discuss here open circuited transmission line. Here simply open circuited transmission line will be seems like this. That means at the load terminal, we are making open circuit. It is open circuited transmission line. That means when it is open circuited means the value of ZL is equal to infinity. Open circuit means it will offers high amount of impedance. So ZL value will be infinity. Then we know that ZOC is equal to Z was open circuited impedance. In our previous discussion, we have assumed this one as a ZSC. Now I am assuming as a ZOC. ZOC equal to Z0 into ZL cos H gamma L plus Z0 sin H gamma L by Z0 cos H gamma L plus ZL sin H gamma L. It is the expression. Here the value of ZL is infinity. This value is infinity. But we are not able to substitute it directly. When we substitute it directly, the entire term will become infinity. So directly we can't substitute this one. We have to do this one as a 0. That means here ZL is equal to infinity. When it will become 1 by ZL, that is 1 by infinity, that will become 0. 1 by ZL will become 0. Now I am making here in terms of 1 by ZL. So that is equal to Z0 into, I am taking as ZL as a common term. ZL from the numerator. So here the rest of the term is cos H gamma L plus here Z0. There is no Z0 term, so it will become ZL sin H gamma L by, from the denominator also ZL, so Z0 by ZL cos H gamma L plus sin H gamma L. Now this ZL will be get cancelled. That equal to Z0 into cos H gamma L, and look at here Z0 by ZL. Here the value of ZL is infinity. So 1 by infinity, that is 0. So this term will become 0 by, here also ZL by Z0. That means Z0 by infinity, 1 by infinity, that will become 0. So this entire term will become 0. The rest of the term is sin H gamma L, and it will become ZOC equal to Z0 into cos by sin. We're getting cot H gamma L. Cot H gamma L. ZOC equal to Z0 cot H gamma L. That it is equation number 1. And similarly, you have to substitute, we have to find reflection coefficient and as well as VSWR. So to find reflection coefficient, we know that reflection coefficient K equal to ZL minus Z0 by ZL plus Z0. Here also we are not able to substitute ZL equal to infinity directly. So I am taking ZL as a common term. Then K equal to, by taking ZL as a common term from the numerator, 1 minus Z0 by ZL by ZL into 1 plus Z0 by ZL. This one will get cancelled. 1 minus Z0 by ZL. That means ZL is infinity here. So it will become 1 by infinity, 0 by 1 plus 0, that equal to 1 by 1, that equal to 1. That is k equal to 1 in case of open circuited transmission line. In case of open circuited transmission line, the value of reflection coefficient k is equal to 1. Similarly, we have to find VSWR. We know that VSWR, voltage standing wave ratio, is equal to 1 plus mod k by 1 minus mod k. That is equal to 1 plus mod k means 1 by 1 minus 1, that is 2 by 0. Anything by 0 is infinity. So VSWR equal to S is equal to infinity. That means in case of open circuited transmission line, VSWR equal to S is equal to 0. S is equal to 0. Now we have to plot the waveforms for this open circuited transmission line. To plot the waveforms for this, we have to consider this equation. Equation 1 we have to consider. Now the equation 1 is ZOC equal to Z0 into cot H gamma L. That is equation 1. That is consider equation 1. By considering equation 1, we are getting like this. Now the same process what we had done in our previous point, we have to repeat here also. Then here ZOC equal to JZ0. And in case of lossless transmission line, again the value of alpha is equal to 0 in case of lossless transmission line. In case of lossless transmission line, the value of alpha is equal to 0. Then here gamma equal to alpha plus j beta. Alpha value 0, then it will become 0 plus j beta. Then gamma equal to j beta. Substitute this value here. Then ZOC equal to Z0 cot H. Gamma is nothing but j beta L. Now I am eliminating this hyperbolic term. By eliminating that, we'll get j Z0 cot beta L. It is ZOC. Expression for ZOC to get the plots. ZOC equal to minus Z0 cot beta L. For this, we have to draw the plot. Just I am assuming here when L equal to length beta L and ZOC. Length beta L ZOC. When length value is 0, beta L, beta is nothing but 2 pi by lambda into L. Here beta is equal to 2 pi by lambda. Beta equal to 2 pi by lambda. Beta L 2 pi by lambda into L 0. That is equal to 0. Then ZOC equal to, from this point, J minus J Z0 cot beta L. That is minus J Z0 cot 0. It will become infinity. That means cot 0 is equal to infinity. Next, when the value of L is lambda by 4, then beta L will become 2 pi by lambda into lambda by 4. That is pi by 2. Then ZOC equal to minus JZ0 cot beta L. That is minus JZ0 cot pi by 2. That is 0. Because cot pi by 2 value will be 0. Next, when L is equal to lambda by 2. Then beta L is nothing but 2 pi by lambda into lambda by 2, lambda pi by, value is pi. ZOC equal to minus JZ naught cot beta L, that is minus JZ naught cot pi. Here the cot pi value is infinity, so it will is infinity. When again lambda equal to 3 lambda by 4, when the length of the transmission line is 3 lambda by 4, then beta L, that means 2 pi by lambda into L is nothing but this one, 3 lambda by 4. This lambda to 3 pi by 2. Then ZOC equal to minus JZ naught cot beta L, that is minus JZ naught cot beta L, nothing but 3 pi by 2. Here cot 3 pi by 2 value will be 0, so this value will become 0. Now with these 4 values, 0 0 infinity, lambda by 4 pi by 4 0, lambda by 2 pi infinity, 3 pi by 4 3 pi by 2 0. With this we have to draw the plot. Now I am assuming here on the x-axis, again on the x-axis beta L, on the y-axis ZOC, open circuited transmission line. Here it is pi by 2, here it is next value is pi, next value is 3 pi by 2, next value is 2 pi, like that the values will be repeats. So when we drawn here, when beta L equal to 0, ZOC equal to infinity, so it is the point. We have already discussed in our previous section regarding to this. So the same plots will be comes here with a 90 degrees phase shift. It will becomes like this, and again like this. When we seen here between these two, 0 to pi by 2, that means 0 to lambda by 4, there is a negative values. 0 to lambda by 4, negative values. So this open circuited transmission line acts as a capacitor in this duration. Next, lambda by 4 to lambda by 2, this is the duration, positive values. It acts as a inductor at L equal to lambda by 4, that means at this value it acts as a short circuit. At L equal to lambda by 2, at this point, lambda by 2 is nothing but pi. At this point it acts as a open circuit, like this. These are the waveforms of the open circuited transmission line. In details we have already discussed in our short circuited line point of view. So I have given here a clear-cut information regarding to this one. If you have any doubts in this, please go to previous topic.